Hello, and thank you for joining me. In this session, we are going to talk about logical operators. As you can see from the example here, the two most commonly used operators are AND as well as OR. So let's go ahead and review the types of operators that we're going to be working with. First off, we start with an arithmetic operator. These are going to be what we see in our mathematical expressions. This is where we have addition, subtraction, multiplication, and division. Next are comparison operators. That's what we use to define relationships between two objects. So we're familiar with the equal sign, and we also have greater than, less than, greater than or equal to, or less than or equal to. Finally, we come to our logical operators. That's what we're going to be going over in this session. Logical operators are utilized like arithmetic operators, only for binary numbers. Also, they allow us to further define relationships between two objects, and we're going to see more of that in a minute. Looking here, we see that our logical operators consist of AND, OR, equivalent, exclusive, implied, and not. Just to emphasize that logical operators are utilized like arithmetic operators only for binary numbers, I want to show you a picture of this calculator. If you notice here, we have actual functions that calculate binary numbers. The method that the logical operators calculate values by are what we're interested in. So what we're basically wanting to do is recreate the functions that's performed by a calculator such as this one here. The only difference is that we're going to be doing with coding. And because we're using binary values, that means we're going to be using true and false values, which is going to be a Boolean data type. Okay, to get started, we're going to start with the AND operator. In the AND operator, the way this works is that all of the expressions must be true in order for the AND logical operator to be true as well. So let's look at our example here. We have expression A and expression B, and then we have our value determined by the AND operator. So here we have the first one, this first row. A is true, B is true. That meets our condition, therefore AND is true. We look at the next one, we see A is false, B is false. Neither one of these are true, therefore AND comes out false. Here we have A is true, but B is false. Our requirement is that all the expressions must be true. That is not the case here. Same thing down here, we have A is false and B is true. Just like before, all of them are not true, therefore the AND operator comes out as false. The only one that comes out true is where we have expression A and expression B both equal to true. So for the purposes of the AND operator, the emphasis is that all of the expressions must be true. Okay, now let's look at the OR logical operator. In this case, any of the expressions can be true, and the OR logical operator will be true, which is much different than our AND operator. So again, any of the expressions can be true, and then the OR logical operator will come out true as well. So let's look again, same setup. Expression A is true, expression B is true. Both of them are true, so the OR operator comes out as true. The next one is both A and B are false. Neither of them are true, therefore OR comes out as false. On our third row, we have A is true, B is false. We have at least one of them that's true, therefore OR comes out as true. Finally, we have A is false, B is true. Once again, at least one of the values is true, therefore the OR operator comes out to be true. Okay, as I said before, our logical operators AND as well as OR are our most commonly used logical operators. Here are some others that we use. We have the equivalent, which if the expressions are equivalent values, they'll come out true. We have exclusive, which is if our expressions are of different values, then the exclusive value will come out as true. And then we have the implied. This one's very specific. This is unless A is true and B is false. Otherwise, it'll always come out true. So let's go ahead and look at the examples that we have. So here we have expression A is true, expression B is also true. These are equivalent values, therefore equivalent is true. They are not exclusive values, meaning that they are not differing values. Both of them are equivalent. Therefore, the exclusive value comes out false. The implied value, let's see, does it meet the criteria, which is A true and B false? No, that's not the case. So it's going to stay true. All right, here we have both of them are false. Are these values equivalent? Yes, they are. Therefore, that one comes out true. Again, they are not differing values, so our exclusive value comes out to false. And again, we don't change our criteria, so the implied value is going to still come out true. Next one we have is A is true and B is false. These values are not equivalent, therefore that is false. The values are not equivalent, therefore they're exclusive. Now, here we finally meet the condition to make the implied operator a false value. Normally, it's always true unless it meets the condition that A is true and B is false, as shown up here. Finally, we have A is false and B is true. They are not equivalent. They are, however, exclusive, but they do not meet the implied criteria to come out as false. So the implied logical operator is always true unless it meets these conditions where A is true and B is false. Okay, now what we're going to do is we're going to start looking at the mechanics of logical operators, and we're actually going to kind of get into the numbers of this. The first thing you want to assume is that true equals 1 and false equals 0. Here we have the number 37, and as you can see right here, we have it listed in our decimal value. Below that, we have it listed as a binary value. They're equivalent. So the first thing we want to go over is how to change something from a decimal value into a binary value. And what you want to look at here is here we have the number 37, and we're going to start high. We're going to say 2 to the power of 7 equals 128. And if you notice, we take 37 and divide it by that number, it comes out to less than 1. So that gives us a binary value of 0, or a logical value of false. We do the same thing again with 2 to the power of 6, which is 64. Again, we take 37 and divide by that value. It's less than 1. So again, we assume a binary value of 0. And again, a logic value of false. Here we get to 2 to the 5th, which is 32. So now we have 37 divided by 32. And we can actually do that one. So now we take it and we say 37 minus 32. We end up with 5. However, since we can go into there at least one time, we get a binary value of 1, which comes out to a logical value of true. From here on out, we're going to work with this remainder value. So if you notice in the next one, 2 to the 4th, which is 16, now we're working with 5. And we're going to say, is that divisible by 16? The answer is no. So we end up with a binary value of 0, which is a logical value of false. Again, we repeat this, 2 to the 3rd, which is 8, no, 0, false. 2 squared, which is 4, 5 divided by 4, it gives us a value of 1, because we can have 4 going there at least one time. We end up with a binary value of 1, which is true, and we are now working with the remainder of 1. 2 to the 1, 2 does not go into 1. We end up with a binary value of 0, and a logical value of false. Finally, we're here to the 0, which equals 1. 1 goes into 1, and we end up with true. So that is how we convert a number from a decimal value to a binary value. More importantly, that's also how we take that binary value and give it a logical value. And that's what we're going to be working with our logical operators.